Greetings. Let's learn assembly of the components what we have already developed in CREO Parametric. Okay. So this time while taking new, you just need to select assembly instead of part and give the name. Okay. We are assembling a flange coupling. So I'm giving the same name. We mustn't give any space. So you can use underscore or hyphen and let it be in default template and press OK. So the new file will get ready. Now we need to import, import the old files whatever we have developed earlier. So here we have a benefit of directly importing just with a press of a button. Just click assemble over here and then browse for the file what you have saved earlier. Okay, we have already developed these parts separately for flange coupling. That is the flange first part and second part. Initially bolt and nut. Okay, other bolts and nuts have also been developed. And then shaft. Okay, we need two parts. So shaft 1 and 2. The same copy is made and the name is changed. Okay, similarly for chunky also have been made. Okay, so let's insert flange 1 initially. Just double click out or else click any one and select open. Okay, it will get inserted and after that you need to place it. Okay, instead of automatic, just you press default because this is the first part we are inserting in the assembly, right? So we need to make it as default. Okay, so after making it as default, it will change its color. You can remove these parts. Okay, you need not to see all these. Okay, so now after it changes its color, just press OK. So this first initial part is fixed. Okay, now we need to insert the shaft inside it. Same method. Okay, click assemble and shaft 1 and press open. So it will be there inside. Now for assembly purpose, either you can rotate this. We have facilities like this. Either you can translate linearly in the X, Y and Z axis respectively to position it, or else you can rotate it. Okay, for our references. Okay, there is a method for assembling. First initially select any surface of the part. Okay, for that you need to select placement over here. If automatic is there, it will automatically assemble the parts. Okay, you have different definitions over here: the distance, angle, offset, parallel, coincidence, normal, coplanar, centered and tangent, and fixed, and default will be there. For the first product only we will be using default. Other products, let it be automatic. If it is if you are not satisfied with the automatic assembling or the constraint type it is selecting, you can change it of your wish, but let us put it automatic at initial stage. Okay, so I am selecting this face to be coincident with this face. There will be a ribbon. Okay, after clicking the face what you need from the component, it will provide a ribbon till where you need to select. So this is the face, it need to be parallel. Okay, so I am selecting that face. Okay, so it's coincident. Yeah, coincident is what I want. So let it be like that itself. If I'm flipping it, if I'm not need this direction, for example, I'm doing, I'll redo it now. So you can press flip. Okay, it will change its direction, but this is not what I need. So I'm going for the previous one. Okay, so this constraint is done. So the second constraint is it must be centered. Okay, this part and this part must be centered. Before that, I need to make a rotation of the whole component. Press the middle button, okay, of your mouse and rotate it. Okay, now you can zoom this part either using the icons over here, using the zoom in to select the respective area. Okay, over here, and go for new constraint. Okay, new constraint, and I need this to be parallel. Okay, this is the, it will go for normal if you put it in automatic. So I need it to be parallel or coplanar. Okay, either things I can use or else coincident. Coincident we won't use, either coplanar or else parallel we'll be using. So let me rotate a little to constraint. So I will select one more face over here. I'm trying to select this face. Okay, over here. Okay, so this face and this face. Okay, need to be parallel or coincident. It's selecting for coincident. Okay, let it be. It's at a constant. Okay, but let it be like that itself. Then I'm going for a new constraint of this circular surface, and before that I can either use concentric or else coplanar. Let's do it in automatic itself. Okay, this face and this face. Okay, it's assembled exactly as per my requirement, but it is little moved inside. So it is at a distance. The first one is changed into distance. Okay, so I need to make an adjustment of that planar. So this is not distance. Actually, this is either parallel or coincident. Okay, it's coincident actually. And the first one is coincide with this part. Okay, let us change it. If we have aligned it mistakenly, we can change it. Okay, I need to move it to this face, not that face. So I'm moving it now. So instead of the flange face, just remove it and select this face instead. Okay, so now the coincident is correct as per my requirement. So the assembly is good now. So after I am getting satisfied with this assembly, just press OK. So this part is assembled. Okay, so I am zooming it to full. Now we need to insert another component. So click assemble and select the chunky one. Okay, just open. So it will be inserted inside. Just rotate for our view. Yeah, okay. Actually, it must be in the opposite direction because the small thing must come over here. Okay, let me do it in another view in a 2D form and I will show you. So, right view. Okay, over here. We have already constructed this parts. Okay, and a small gap is there at this. Let me zoom and show you. So there is a taperedness. Okay, there is a reason behind it. Why we have taperedness. After assembling, I'll say why we need that and why we designed in that way. The taperedness you can see over here. From here till here, there is a taperedness. Okay. So let me zoom out a little. Before that, let us check. Okay, so we need to rotate. Okay, the small side is over here and the bigger side is over here. Just we need to rotate in opposite direction. That's what it said. Let me show you. Right? Oh yeah, so it need to be opposite side because the smaller side is over here and the bigger side is at this part. The same thing must be here for the flange. I mean chunky too. So we need to rotate. Let me come to normal mode of rotation. Let's go for shading with edges. Okay, but just I shall rotate like this for my reference. Okay, clicking this part, I can rotate. So this is my required place. So over here, so once again I can select in a way like make this part coincide. We zoom and do it. Now it's coincident and let's check whether it is exactly parallel as required. from the right view we can confirm it. Okay, so now let's zoom and check whether it is as per our requirement. Now it is in opposite direction, so we need to flip it over. Okay, so that's what it said. So once again I'm rotating a little. Going for new constraint. Before going for new constraint, I need to rotate it 180 degrees. Yes. Now it would be parallelly matching. Let's confirm and then we will match. Probably that phase. Okay, so now I can confirm this coincident. Okay, in the new constraint, you can go for a component item, select this phase. The above phase of this part. Set angle offset, we need to make it at 0 actually. Or else you can go for coincide also. This part. So it's done perfectly. Now I'm going for normal shaded with edges. Okay, new constraint I need to select. So in this new constraint, I need to select this face and this side face. So it will be at distant. Just either you can use coincide or else just make it as 0. Okay, coincide, it's getting perfect. Yes, so it's perfectly assembled. You can rotate and check whether the product is perfectly assembled. Yes, it's perfectly assembled. And press OK. This part. So let's check through the cross-sectional view whether the alignment is perfect. Right. With hidden line. So zoom and check. Yes, it's perfectly matching at this part. So the shunt key is inserted. Okay. So now let's check the whole view. Let me bring it to normal view. Shading with the edges. Okay, same way we need to assemble other parts also. Okay, let us bring in another one. Getting a flange. Okay, as usual we will get the second flange part. And before assembling, let us assemble shunt key for that as well as the shaft for this part. Then we shall assemble the whole unit with the required part. Okay, so let it be like this itself. For initially we can edit it so that you will learn that option also. So let it be like this itself. So once again I am inserting the second shaft 2, and in the same method. Okay, we are going to assemble in the same method. Okay, selecting this part first and then this face. Now we can go for internal surface. Okay, this face that is coincided. Yes. Then go for placement and click new constraint. For the new constraint, once again we need to make the coincidence of this face. Let me zoom and do it. That would be easy. So this part with this side face. Yes, it's made. For the new constraint, somewhere escape, but we can view this coincident. Okay, so we can select the surface over here and make it concentric or coincide with this part. Okay, so it is perfectly aligned, I think. Yes, it's perfectly aligned as per expectation. So just press OK. Now insert the second chunky tool, the same method. Over here, I'm rotating it. Same way, I need to zoom it a little. Select this face. Align it with this face. This is coincide. Before going to new constraint, I can check over the right whether it is exactly as per the requirement, the parallelism. So I'm going for my right view. Same way, I need to rotate it top to bottom, I think. Okay. So the same way, I need to rotate it. So once again, so I need to coincide this face now. Drag it towards the required face. Set a distance, but I need it to be coinciding. So make it coincident. It's done. Same method, I need to select this face. Okay, let me zoom a little to avoid those issues. Make a new constraint. Select over here. Zoom out a little. And this face. It is at a distance, so let it make it to be coincide to each other. It's done. Okay, let's check whether it is correct or not. Okay, over here there will be a small gap at the bottom. Same way there must be a gap at the side. Yes, I hope it's perfectly aligned. Yes. So we have finished this part. So just press OK. Confident with that part. Now we need to align these two together. So you can select this flange, the second flange, okay, and then right click it, and then you need to edit, or else you can click one more time and go for edit the definitions. Okay, so now I can give the placement for initial constraints here with this face will be coincide, but I need to be flipped. Okay, so I'm flipping it. Now I need to make it aligned, this part. So new constraint, this face with this face. Yeah, it's coincident. Okay, so it's perfectly matched. And one more time, I need to make a new constraint of this opposite part, this face. Okay, so with this face. over here. Yes, so it's aligned perfectly, I think. Now you can rotate and check whether it is correct. Yes, it's correct. So if you click OK, the rest part will come down. Okay, so now we can check, rotate and check. So all the parts are perfectly aligned with each other. Can also confirm it. Okay, so shaft and other things are perfectly aligned. Now we need to fix those two flanges with respective bolts and nuts. Okay, so for that, now we are going to insert the bolt what we have designed earlier. That is M16 bolt. Zoom out a little. We need to make that face perfect. So I'm selecting this face over here. Okay, need to be aligned with either side. You can choose either side of your choice. I'm selecting this side. Okay, it would be defaultly normal. I need to coincide. So I'm coinciding it. Yes, it's done. And then either one hole we can fill and make it as an array also. Okay, so new constraint. Select this surface and any hole you want. Okay. So let us go for this face or also over here. Okay, so let us assemble over here better. So this is coincided. Okay, so yeah, it's perfectly aligned. Now we can insert the nut. We just press OK. Okay, nut insertion, it will a little confuse, but we shall try it out. Okay. The same methods we can choose. Assemble for nut. Okay, so zoom all. The nut is over here. Can use the same method. Selecting a face over here. Let's zoom a little. And it must coincide with this face, right? So it is at a distance, so better we shall go for coincidence. Yes, it's done. Constraint better, I will make it aligned with the axis first. So now we select the axis part. Okay, I need to select the axis of this. Okay, the axis is selected. Similarly, the axis of that nut also need to be, bolt must be selected. Okay, so yes, it's made. Instead of distance, I need to make it as coincident. Yeah, it's assembled actually, but it won't rotate. Okay, so that I am removing the previous coincidence. Okay, of that face. Okay, that Okay, so only this axis coincidence is there, and in the new constraint, let me move it linearly out. I'm selecting the threaded parts. Okay, over here, the part of over this face, I can select any threaded area. Okay, it's tangented automatically. Let me zoom overall. It's okay. Now I can move and check. Okay, but let me assemble it fully. So one more time I need to give a new constraint and then select this face with this one. Okay, it would be at distant. I need to make it at 0. Yeah, okay. So it's aligned perfectly. So this is how it's done, and press OK. So this part is finished. Okay, let's try to make it as a polar array now. Okay, let's make the same component. We have assembled it already, so we can make the same component to be instantly pasted to other parts. So I am selecting one component. So initially bolt. Okay, I'm making as an pattern array. So over here, I'm selecting get the reference. It's already there probably at the pattern, and the final part also need to be selected at instances. Reference is actually my axis. So this is the axis I am selecting. So the 4 components are there. Number of members I need 4. So at 90 degrees. So it is already placing itself. Okay, just press OK and check whether it's perfect. Yeah. So the bolts are assembled perfectly. The same way I need for nut. So once again I'm clicking the nut, and in the same method. Okay, better I'm selecting this nut over here and go for pattern, this part, and the same instance I need to give for the reference, going for axis and select this axis, and 4 parts are there, and press OK. So all have been coupled perfectly. This part. So the bolt and nuts have been coupled perfectly with this instances, and you can check it whether it is assembled correctly. Yes, but it's totally assembled perfect of the flanged coupling with the bolts and nuts with inserted key shank in the perfect alignment. Okay. Okay. Thank you.